Yeah. Hello, can you hear me? Hello, can you hear me?
Yes,
How are you guys doing?
good.
All right. Let's begin. So I will start by taking you to the course room so you can see, we can take a look at the what you need to complete this week. Okay, so let me share this for you with you guys. Right, let's start with my announcement. This is my announcement for the week. I just want to make sure that you're seeing this. So we're now in week 6. Okay, I'm going to open it. So we continue with chapter 4. Hopefully we might finish it tonight. Then for the assignments, you have 3 assignments. One is a classwork 6, which I will make available after this class session. Then complete homework 9, homework 5, and then Excel assignment 3. All these are due on this September 29, which is this Sunday. And of course, you know that you can have access to this assignment by going to the models and then scrolling down to module 4. This is where you see the classwork. Some of you have already done the classwork. That's excellent. Actually, this is the old one. What we have is classwork 6, I believe. Let me see. Yeah, classwork 6. So if you go to the models, you can see, let's scroll down to where we have classwork 6 in module 4. You can see right here, Bayes' theorem. Hopefully we can finish everything and then you can begin Excel assignments. Some of you have already done the Excel assignment, which is very good. So let's begin. Tonight, we continue from where we stopped last week, which is on classical probability. Remember classical probability, where you calculate the probability of an event using the sample space, the event sample space. I mean, based on the event sample space, that's the goal. So with this example last week, now let's continue with another example, roulette. I'm sure you guys know what a roulette is. This is how it looks. It's a game that is played at a casino. Okay, it says here, if you to refresh your memory, for classical probability, this is the formula we use. The probability of event E equals number of ways event E occurs, or number of outcomes in event E divided by total number of outcomes in the sample space. A simple way of saying this is that the probability of event E equals number of ways event E occurs divided by the sample space. So having said that, we can now proceed to the next one. This one says, a roulette. Well, let me make sure I'm saying this. A roulette wheel has 38 slots. Number 0, 0, 0, 1, 2, 3, all the way to 36. Half 1 through 36 are red, and the other half are colored black. The remaining the remaining one, which is called 0 and 0, 0, are colored green. So find the probability that a ball lands on A, a black number, B, a green number, C, a 10, and D, an odd number. Okay? So to answer this, you look at the roulette, you can see that half of this are colored black, and the other half are colored red. And the 2 greens, 0 and 0, 0, you can see them here. And it says, so half of 1 to 36 are colored red. That means 18 are colored red and 18 are colored black. Then we have 0 and 0, 0. That means you have a total of 38 slots, out of which 18 slots are colored red and 18 are colored black. So to be able to answer this question, we need to know all these facts. So we begin by using B for black, G for green, and red, for R for red. And we have that, okay. Half of red, 12 of 18 of them, because you say half, 1 through 36 are colored red. Then black, B, is also 18 of them, because it says, and the other half are colored black. Then it says that the remaining 0 and 0, 0 are colored green. So for green, green are 2 of them, 0 and 0, 0. So that means that the total sample space now becomes sample space becomes the total. Sample space will be the total of this. Here. Okay, let's see. I will be you add all this 18 plus 18 plus 2. That means 38. Sample space should be 38. That'll be 38. So total 38 slots in that roulette wheel. 38 slots. That gives us the sample space. Okay. 38 slots. Give us the sample space. Total. So now we can now that we have the sample space, have the individual figures, we are ready to start our calculations. It says find the probability that a ball lands on a black number. So and let's start to do that one for A. So for A, the probability that it lands on a black number, which is PB, pure black. There are 18 blacks. 18 out of 38. Out of 38. So 18 over 38, from the calculator, we can get the value of 18 over 38. So we have our calculator right here. So we can share it. 18 divided by 38 was 0.474. 0.474. Okay. 0.474. Or if you like, you can say that there is 47.4% chance that the ball fall on the black slot. See? And the second question says that to find the probability that the ball fall on the green number, that's part B. The probability that it falls on the green number, which is P of G, will be, how many green numbers do we have? We have 2 of them, green. So it's 2 out of 38. Which is, on the calculator, 2 divided by 38. Okay. 2 over 38. Which is 0.053. 0.053. Or you can say that there is 5.3% chance that the ball falls on the green slot. Any question on these two so far? Any question, class?
No questions so far.
Okay, good. Excellent. Excellent. Now it says that if fall on the number, the slots that have the number 10. If you look at the S plus B, that means part C, that if 4 on 10, probability of that is 4 on the slot that have the number 10 on it. Okay. In that case, let me put this, okay. In that case, what you're gonna do is you scroll down, see how many slots have the number 10 written on it. See, look at it. They are roulette. So there's only one, you can see the 10 right here. There's only one 10, only one of them. So that the probability that it falls on the slot that have 10 on it will be 1 out of 38 slots. So that will be 1 divided by 38, 0.026. 0.026. That's 0.026. 0.026. Or if you like, you can call it 2.6% chance that it falls on the slot that have number 10 on it. Okay. And the last number says, last question says that to find the probability that it falls on an odd number. Well, if you look at this, half of this 1 through 36 are even, and the other half are odd. So 36, I mean half of 36 is because 0 and 0, 0 and 0, 0 are not odd. They don't belong to odd number. So just 1 through 36, which is 18. Half of them is 18. So that the probability that it fall on the odd number will be odd. Maybe equals 18 over 38. Which will be, given that we have it already here. Excuse me. 18 over 38. So you have it here already, something similar here. This is 0.474. See? Or if you like, you can call it 47.4% chance that it will fall on the slot that is odd number. Okay? So that's how we do it. You get the sample space and then, you've calculated the probabilities. Get the sample space, get the individual outcomes, and then calculate the probabilities. So at this point, we can you hear me? Hello, guys?
We can hear you.
Okay, good. All right. So let's go to the next example here. At this example, we'll be looking at the basic probability rules. Let me bring it down. The basic probability rules. I will take you to where the rules are located. Let me take you to where they are located. So we can examine them. These are the rules right here. It's inside the same document. First one says, rule number 1. The probability of event E is a number, either a fraction, a decimal, or a percent, between and including 0 and 1. And this is how we write it here. The probability of E is less than or equal to 1, but greater than or equal to 0. This means that the probability of an event can never be negative. Can never be a negative value, and it can never be greater than 1. That's what this rule is saying. Second rule says, if an event E cannot occur, then its probability is 0. So if it cannot occur, then the probability is 0. Rule number 3 says, if an event E is certain to occur, then the probability is 1. Okay. Next rule we are going to examine is the one we call complementary rules, but I will take you to where we do it with an example. So let's go to where we have complementary rules. We complement events. Okay. Now, two events, the complement of an event E is a set of outcomes in the sample space that are not included in the outcomes of event A. That means basically it's a way of saying the opposite. For example, the complement of you being in class here with me is you not being in class. Complement of sitting down is standing up. So complement is basically the opposite of something. So we use this symbol to represent complement. E with a small c at the top. Say E complement C is C. And again, remember that the complement is opposite. Let's see this question. It says, find the complement of each event. The first event says, selecting a letter of the alphabet and getting a vowel. So let me write solution so we can answer that question. Solution. Okay. Part A says, A part says, selecting an event, selecting a letter of the alphabet and getting a vowel. The complement means not getting a vowel. So we know, of course, we know that there are 5 vowels in English language: A, E, I, O, U. So the complement of getting a vowel is not getting a vowel. Okay, that means it means getting the consonants. So so that means here it means getting B, C, D, E, no E, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. It's a complement of getting a letter of the alphabet and getting a vowel. I mean, selecting a letter of the alphabet and getting a vowel. Part B says, selecting a month and getting a month that begins with J. The complement means getting a month that does not begin with J. So that means that the complement for this event will be getting, January. Oh, sorry. Remember, it says selecting a month and getting a month that begins with J. The complement means getting a month that does not begin with J. That means February, March, April, May, August, September, October, November, and December. Okay. And December. Getting all this. That a complement. Any question on this? Any question? Excellent. 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 Now listen, these are the complement rule. It said the probability of E complement equals 1 minus probability of E. And we can use this to solve questions involving probability. Let's look at one example here. It says, remember this is the rule right here. The probability of E complement equals 1 minus probability of E. Let's try this one question. Okay, it says, in a lottery game, each player chooses a 3-digit number between 000 and 999. Okay, a player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket loses the game. So the event win, let's say that the event win is W. The opposite is to lose. And we'll use W complement for that. So here it says a player wins if his or her 3-digit number is chosen. Now remember, the number goes from 000, okay, to 999. See? So the player wins if any of his numbers are chosen. So I'm from 000 to 999, I mean 000, 001, 002, 003, all the way to 999. That means 1,000 digits. Now, it's find the probability that a player wins. So find the probability that a player buying a single ticket loses the game. That means it says to find the chance that they lose the game. That means you need to find a complement. So that the probability of W complement, let's find the first of all, let's find the win, the chance that they win. So they say the event win is W. So that the probability that they win, that means W, will be, he said this player bought a single ticket. That means the chance of winning is 1 out of 1,000 tickets that were sold. That means 1 divided by 1,000. We can get that from the calculator. Okay, 1 divided by 1,000. 0.001. 0.001. Okay. 0.001. So that we're looking for the probability that he loses or she loses. That means we're going to do probability of the W complement, WC, which is the complement, maybe, let me adjust this. Okay. Maybe 1 minus the probability that he wins. 1 minus probability that he wins. Okay. Which is equals to 1 minus 0.001. So 1 minus that. 1 minus 0.001. I mean, 0.999. 0.999. Or I can say that the player has 99.9% chance of losing. 99.9% chance of losing the game. Any questions on this one? Excellent, excellent. No question. Good. So this time we can now explore empirical probability. Oh, excuse me, I need to bring that. Under empirical probability, we don't know what the sample space is. So that means we have to estimate the sample space by ourselves, and then by of course observing the number of occurrence of the event through an experiment. Then after that, we can now calculate the probability from a relative frequency distribution. So that means that under the empirical, we calculate the probability of an event using this formula here. Probability of event E equals frequency of event E divided by the total frequency. Let's apply this to this question here. Okay. So it says, let me bring it down so you can have enough room for it. It said that here that hospital records indicated that maternity patients stay in the hospital for the number of days shown below. Those that not see number of days they stayed and the corresponding frequency. You can see that those that stayed 3 days are 15 in number. Okay. Now, those that stay for 4 days, 32 in number, 5 days, 56, and so on and so forth. It says, find these probabilities. The patient stayed exactly 5 days. B, a patient stayed less than 6 days. C, a patient stayed at most 4 days. D, a patient stayed at least 5 days. Okay, let's answer all these questions. Okay. First one says, first needs to find the total of this. Let me write this down so we can get the total of that. So I got we got 15 plus 32 plus 56 plus 19 plus 5. So let's go and get the total from the calculator. The total will become our sample space. 15 plus 32 plus 56 plus 19 plus 5. 127. 127. So you can go and put it right here. 127. 127. So now we are able to answer these questions since we have the sample space. Now, I said a patient stayed exactly 5 days. Right here. A. The patient stayed exactly 5 days. Okay. P of 5 days. 5 days. P of 5. Okay. If you like, I can complete 5 days. So I'm gonna unbold it. Will be equal. Now look at the chart. 5 days is 56 patients stayed 5 days. So that's will be 56. 56 out of 127. 56 out of 127. From the calculator, we have 56 divided by 127. 0.441 rounded. We round it 0.441. 0.441. Then B says a patient stayed less than 6 days. This is 6 days here. So less than 6 days means 5, 4, 3, or 3, 4, 5, you know. So it says patient stays for less than 6 days. So you're gonna be you cannot count 6. You're gonna be 3, 4, 5. So you gotta be probability of 3 plus probability of 4 okay plus probability of 5. That's less than 6 days because you cannot include 6. Okay. So let's see the results. For 3 days, you have 15% out of 127. 15 divided by 127. Plus, for 4 days, we got 32 divided by 127. 32 by 127. Plus, for 5 days, we have 56 by 127. Okay. So I give you the answer we are looking for. So I'm going to write this down so you can go and check it from get the answer. 15 over 127 plus 32. 127 plus 56. 127. Okay. Let's go and put it in the calculator and get our answer. Okay. There you go and put and get our answer right away. So we got we got 15 divided by 127 plus 32 over 127 plus 56. 0.811. 0.811. 0.811. So that the probability that the patient stayed less than 6 days is 0.011, 0.811, or 81, there's 81.1% chance that they stay less than 6 days. The next one will be the patient stayed at most 4 days. At most 4 days. At most 4 days means 4 days or less. What it means. So that's part C. The probability that the patient stayed at most 4 days. Yeah. Because now I'm make this on bodies. See 4 days. I mean, for at most 4 days means 4 days or less. I mean, it's P of 3 and P of 4. Probability of 3. Okay, plus P of 4. This gives us for 3, we have a 15 over 32. That's not sorry, not 15, sorry, my mistake. 15 over 127 plus for 4. 32 over 127. Okay. Which will give us the answer, which so I have it here on the calculator. I just gotta remove one number there. Okay, I have to remove this one. Okay, I'll give me 0.370. Okay, 0.370. Okay, 370. The last but not the least, there will be a patient stayed at least 5 days. At least 5 days means 5 days or more. That means we're gonna use 5, 6, and 7. Okay. D, I believe. The probability that is still at least 5 days. 5 days equals I can say 5 days or more. I'm just going to count 5, 6, 7. Yep. Probability of 5 days. P of 5 days plus P of 6 days plus P of 7 days. Say 5, 6, 7. See? 5, 6, 7. Okay. That means for 5 days, you have how many stay for 5 days? 56 over 127. 56 over 127 plus, it's about 6 days. So we go to R 19 over 127. Plus for 7 days, 5 over 127. And that'll give us the probability that the patient stayed at least 5 days. So let me write this down so we can get the answer from the calculator. 5 over 56 over 127 plus 19 127 plus 5 127. Okay? So let's figure this out. I'll take you the calculator so we can now use it to figure this out. Here this we have the 6 by 127 plus 19 127 plus 5 over 127. Let me see what if I'm forgetting anything. No, I'm not. Just take it there. Here, I'd say at least 5 days. I mean 5 or more. 56 127 plus 19 over 127 plus 5 1. Okay, click it there. Something I have here. Okay, 19. All right, 0.6299. That means 0.630. If you round this, 0.630. Okay, 0.630. Okay, so that's give us the probability that the at least the patient stay at least 5 days. Yeah. So that's tell us empirical probability. Any question on this one? Any questions, scholars?
No questions.
Good, excellent. So let's look at more concepts and probability. The first concept we look at is what we call mutual exclusiveness. Two events are said to be mutually exclusive if they cannot occur at the same time. That means if one event is occurring, then the other one will not occur. For example, you being here now, you cannot be here and not be here at the same time. So either you are here or not. How about this? Being a Democrat and a Republican. You cannot be a Democrat and a Republican at the same time. Either you're a Democrat or you're a Republican. Another one is getting a coin. Of course, you know a coin. A coin, you can see the coin. You cannot have head and tail at the same time. Either you have head, if you toss the coin, either you have head or you have tail. Okay. Now, if you are in an intersection, if you approach an intersection, either you turn left or you turn right. You cannot turn left and right at the same time. So they are mutually exclusive as well. Now, event getting a king and an ace in one card, not possible. Yeah, because they are mutually exclusive. Now we look at the dependent event. Two events, A and B, are dependent if the outcome of A affects the outcome of B in such a way that the probability of their occurrence changes. For example, events having a good grades and getting scholarship are dependent. If you have good grades, you get scholarship. Now, two events, parking in a no parking zone and getting a parking ticket are also dependent events. Yeah. Now, drawing a card from a deck. You know, a deck of cards have 52 cards. If you draw a card from a deck and it didn't replace it, it is no longer 52, it's now 51. And that can affect the probability when you calculate it. So drawing a card from a deck and not replacing it, then drawing a second card, they are dependent events. Another way of saying it is to say that sampling without replacement is a dependent event. For independent event, two events are independent if the occurrence of one event cannot in any way affect the occurrence of the other event. Okay. So, for example, if you win the California lottery, that doesn't mean you win a Maryland lottery. Another example is when you select a card from a deck, getting a queen, replacing it with before selecting a new card. So the card is 52. You select one, it's 51. You replace it, it's 52. So it won't change the probability of the event. That's another good example of independent event. Now, this we can now look at the rules that as they apply to this event that I just mentioned. Let's start with the addition rule. Addition rule. It says the probability of event A or B is the probability of event A plus the probability of event B minus the probability of event A and B. This is the addition rule. Okay. Now, and if there are three events, it continues like that. The next one is the multiplication rule for independent events. If two events are independent, the multiplication rule says, but before I do that, for addition rule, the keyword there is or. When you see or, that means you're going to use addition rule. For multiplication rule, is the key is and. For example, you see here, the probability of A and B will be the same as the probability of A times probability of B. And if there are three events, you have probability of A and B and C will be P of A times P of B times P of C. Now, if they are dependent, it changes. It's the same multiplication, but it changes the letter. For example, probability of event A and B, if they are dependent, will be the probability of event A. That's the probability that it will occur times the probability that a B will occur, given that A have already occurred. Remember that the forward slash that means given that. Okay, I mean given that. Let me bring the student in. So you got three events. You have the same process. You have probability of A and B and C equals P of A times P of B given A times P of C given AB. So let's look at how it works. Okay. It says here, at a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. If a person is selected at random, find the probability that he or she is either a Democrat or a Republican. See, the keyword there is or. Okay, good. So see, so or is the keyword here, or. This or tell us that we are going to use addition rule. Okay. Now the first thing is to get our outcomes out. Okay. Solution. You have R for Republicans, D for Democrats, and I for independents. So we have how many in this rally? How many are Republicans? We have 20 Republicans. I'll close it. How about Democrats? We have 13 Democrats. Okay. Okay. Then independents. We have 6 independents. Okay. So the total now become total 20 plus 13 is 33 plus 6, 39. So that's the sample space. Yeah, will be 39. So 20 plus 13 is 33 plus 6, 39. It's going to be 39. Draw a line under it. Sample space will be 9. So we can, with that, we can be able to answer the question. You break it down to this fashion, then you can begin work on it. Okay. The question was, if a person is selected at random, find the probability that he or she is either a Democrat or an independent. So we're looking for the probability of Democrats or independents. That would be the probability of Democrats plus probability of independents minus probability of Democrats and independent. Now remember that this is a derivation of the formula. Now remember the formula we use is here. P of A or B equals P of A plus P of B minus P of A and B. That's how we're able to get this formula here. So plugging this in, you can have equal. Democrat, there are 13 of them. 13 out of 39 plus we have independent 6. 39 minus the Democrat and independent. You cannot be a Democrat and independent at the same time. So this side will turn to 0. But at 9. That will give us the answer. So let me write this down so you can get it. I got 13 over 39 plus 6 over 39. So got plus, okay, minus 0 over 39. Minus 0 over 39. So have 13 over 39 plus 6 over 39 minus 0 over 39 0.487. 0.487. Yes. So that the probability that the person is either a Democrat or an independent is 0.487. Okay. So that's how we solve this kind of question here. We can now look at more examples. More examples. Does anybody have a question before we go to more examples? Yeah. So, excellent. So no question. Good. Let's look at the a scenario. Says, let me get something for my folder. I can't believe I put this thing back. Okay. Yeah. Next one is this one. It says a card is drawn from an ordinary deck and then replaced. A second card is drawn. Find the probability of getting a queen and an ace. In this case, the keyword is and. And add is a multiplication rule. So this is the card right here. So let us use Q for queen and A for ace. We have how many queens? I can see the queens right here. 1, 2, 3, 4. And ace here. 1, 2, 3, 4. So queen and ace. Talking about queen and ace. Okay. I have people coming in, so let me just check their names. Okay. Okay. All right. So queen and ace. So we have 4 queens and 4 aces. It said that the card is drawn from the deck and then replaced. Then a second card is drawn. Find the probability of getting a queen and an ace. Again, and is the keyword. And this is a multiplication rule. Okay, so the probability of queen and ace, P of queen and ace would be the P of queen times probability of getting an ace. Okay. Again, there are 4 aces here. And for queens, for queens, that means 4 out of 52 cards for queen. Times for ace. You can see the 4 aces right here. 1, 2, 3, 4. So we have 4 over 52. And that will give you the answer. We're getting a queen and an ace. You have 4 divided by 52. Okay, times 4 divided by 52. Okay, 0.0059. 0.0059. So that the probability of getting a queen and an ace is 0.00. I mean, normally the way they do the drawing, draw the first card, then before you draw the second card. So the required probability is 0.0059. Any question on this one? Any question? Excellent, excellent. So let's look at this one then. Said a person owns a collection of 30 CDs, of which 8 are country music. If 2 CDs are selected at random, find the probability that both are country music. In this case, we use C to represent country music. And say that a person have a collection of 30 CDs, out of which 5 are country music. If the 2 CDs are selected at random, find the probability that both are country music. So you select the first CD, country music, second CD, country music. So what is that probability that the chance of occurring? So we're looking for the probability that C1 is a country music. That's the first CD. And second CD, C2, is also a country music. That will be, let me adjust this. Excuse me. Yeah, let me see. Make sure you're seeing this. Okay, country music. Let me adjust this. Okay, let's see. It just, well, just one control plus. It won't make it. Okay, anyway, I'm gonna use this. Then country music C1 and C2. So it's gonna be probability of C1 times probability of C2. Okay. C1 times C2. That's what we're looking for. Okay. So in that case, we have again, we'll only adjust this. Okay. Make it sub and make this one sub as well. Okay, now remember this question didn't tell us that it was replaced. When they say if two series are selected at random, it didn't say whether if they are replaced or not. So we assume they are not replaced, because if they are replaced, they will tell us that they are replaced. So you have the required probability as there are two CDs. First, before they made the first, remember, a person have a collection of 30 CDs, of which 5 are country musics. So before he made the selection, there are 5 country music out of 30 CDs. That means 5 or 30 times, then he made the selection. Now, if I made the second selection, there are now, he didn't replace it. So we now have 4 country music out of now 29 CDs, because he didn't replace the first one. And this will give us the answer we are looking for. Yeah? Okay. To give you the answer we are looking for. So you have 5 over 30 times 4 over 29. So we got 5 divided by 30. Okay. Times 4 over 29. 0.023. 0.023. Okay. And let's answer the questions. Okay. Any question on this?
No questions so far.
Good. Excellent. Now let's look at this one then. It says here, Harris poll found that 46% of Americans say that they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 will say they suffer great stress at least once a week. So let's use S to suffer great, meaning to suffer great stress. And we are told that 46% of Americans say they suffer great stress. That means the probability of suffering great stress and P of S equals 46%. Okay, which is 0.46. Now, you see that 3 people are selected at random. To find the probability that all 3 will say they suffer great stress. Okay? So that means we have this for general. So that means for 3 people, it means that let me bring this down so we have enough room. Or maybe bring it up so we have enough room. Okay? It means that we're looking for the probability that the first person, S1, say that they suffer great stress. And the second person, S2, say that they suffer great stress. And the third person, S3, but there are 3 of them, say that they suffer great stress. That means we're gonna have highlight this and then excuse me. Make it sub. Okay. Sub. Okay. And it's gonna have probability of S1 times probability of S2 times probability of S3. Okay. Let me make them all sub. All sub. All sub. Now, with this, we can now answer the question finally. Since we have this, we are told that 46%, that means 0.46. So this gives us So it's going to be 0.46 times 0.46 for the second person times for the third person 0.46. And that will give us the answer we are looking for. 0.46 times 0.46 times 0.46. So let's go and put it in. 0.46 times 0.46 times 0.46. 0.097 rounded 0.097. 0.097. That's the answer for this. So that the probability that all three see the spaghetti stress at least once a week is 0.097. Okay? So that's how we solve this kind of question. Let's look at this type, the one that they put in a box like this. Okay? The one they put in a box says the result of 985 pedestrian deaths that were caused by accidents are presented below. You can see the pedestrian deaths. Pedestrian intoxicated, driver intoxicated. Okay, let's say, is the pedestrian intoxicated? Let me put it this way. Is the pedestrian intoxicated? Is he? Is it yes or no? This is the yes, no for pedestrian, then yes, no for driver. I mean, is the driver intoxicated? Yes and no for that. So it says, if one, A part says, if one pedestrian death is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. Yeah. As B says, if two pedestrian deaths are randomly selected with replacement, what is the probability that in both cases, both the driver and the pedestrian were intoxicated? Yeah. So now let's see. First thing to do is to get the totals for all this. So I'm going to write this down so we can get the totals for all of them. Okay. So I'm going to do the first one, 59 plus 79. 59 plus 79. So you can get it from the calculator. 59 plus 79 is 138. So you can go there and put 138. 138. Next is 266 plus 266 plus 581. 266 plus 581. Let's go and get it. $266 plus 581. 847. Let's go there and put 847. 847. Then let's do these columns. We got 59 plus 266. 59 plus 266. Okay. 59 plus 266. 325. 325. 325. Then this one is 79 plus 581. 79 plus 581. So I got 79 plus 581. So I get it. 79 plus 581. 660. Let's go and put it right there. 660. Now we need to get the grand total, which is 138. Either you do 138 plus 847, or you do 325 plus 660. Let's do 138 plus 847. $138 plus 847, 985. $985. So if you do this one, 325 plus 660, you also get 985. So now, once you finish the adding, next thing you are ready to solve your equation. So we use P to represent pedestrian was intoxicated. P complement means pedestrian was not intoxicated. D, driver is intoxicated. And D complement, driver is not intoxicated. The first question says, if one pedestrian death is randomly selected, find the probability that the pedestrian was intoxicated, or, see the keyword or the driver was intoxicated. The pedestrian was intoxicated, or the driver was intoxicated. So that means this is the P or D. That means probability of P. That means the probability that the pedestrian was intoxicated plus the probability that the driver was intoxicated minus the probability that pedestrian and driver was intoxicated. So we just put numbers in. We're using the totals we have there. This one is the probability that the pedestrian was intoxicated. That means PP. This is the pedestrian. Is the pedestrian intoxicated? Yes. So you're gonna use total, which is 325 out of 985. Out of 985. Plus, next one is PD. That means probability that the driver was intoxicated. See, is the driver intoxicated? You see yes right there. The total is 138 out of 985. Minus, say, let's just say probability that both the pedestrian and the driver were intoxicated. See, this is the yes for pedestrian. This is the yes for driver. You can see this represents both the pedestrian and the driver was intoxicated. That means 59 out of 985. That'll give us the answer we are looking for. Let me write this down and get the answer. I got 325 over 985 plus 138 over 985 minus 59 over 985. Okay, let's go and get this answer from the calculator. You can get it from the calculator right here. So I got 325 over 985. Okay, plus 138 over 985. Yeah. The minus 59 over 985. So give me 0.41 410. So answer is 0.410 rounded. .410. Okay. With that give us the probability that the pedestrian was intoxicated or the driver was intoxicated. And then this part says, it says if two pedestrian deaths are randomly selected with replacement, what is the probability that in both cases, both the driver and keyword and both the driver and the pedestrian was intoxicated? That means both of them we are not intoxicated. Yeah. Okay, this is the pedestrian was not intoxicated. Is the pedestrian intoxicated? No means that they were not intoxicated. And for driver, no means they are not. So this is the intersection, 581. So that this means both the pedestrian and the driver was not intoxicated. And this time they selected 2 pedestrians. So that means the probability that both of them are in that case, both the driver and the pedestrian were not intoxicated. That be 581 because there are 2 of them. We're looking for the probability that pedestrian was not intoxicated. That means P complement. And the driver was not intoxicated. Yeah, what that means D complement. DC equal. Let me adjust it. I got. Okay. Yeah, and this one. Yeah. Gonna be since this represents both of them, I'm not intoxicated. I mean, there are 2 of them. That means 581 over 1 over 985 times 581 over 985. So instead of writing it that way, you can just write 581 over 985 raised to the power 2. That means it's to save time. So you have 581 over 985. Okay, times 581 over 985. That'll give us the answer we're looking for. So I can just do it raised to the power 2, since that's the same thing, 581. Okay. So I'm gonna write it down. 581 over 985 square it. I'll give you the answer right away. So take you to the calculator. You got 581 over 985 square, since there are 2 of them, 0.348. 0.348. Uh, 2.348. So there is 34.8% chance that if 2 pedestrian deaths are selected at random with replacement, that both will be both the driver and the pedestrian will not be intoxicated. That's what it means. Okay. So having said that, we can then move to another topic we called conditional probability. I've explained the examples. Now let's look at what we call conditional probability. Now, the conditional probability of an event, as you already know, in life, everything have condition. To pass exam, you need to study. Do many examples, then you pass the exam. Another one is this. CSC. To get a job, you have to get the qualification, get the education and the experience, and you get the job. That's the condition, is to get the qualification through experience or through education. Even love, they say love is also conditional too. Because somebody loves, the lady loves you because you have money or because you're handsome. That's the condition. And you love her because she's beautiful. There's always a condition for that. And we recognize that in statistics. We call it conditional probability. So that means the conditional probability of event A occurring, given that this / means given that. That's what it means. It means given that. So the probability of event A occurring, given that event B have already occurred, where B is the condition, equals the P of A and B divided by P of B. Let us look at an example here. Yeah. Say the test results for marijuana use is presented on the table below. This is the test results for marijuana use right here. Does the subject actually use marijuana? I see yes and no. You can see positive results and negative results. And you can see their totals, column totals and row totals. The question says, choose one subject at random, then find these probabilities. A, the subject tested positive, given that he or she actually uses marijuana. B, the subject actually uses marijuana, given that he or she tested positive. C, the subject tested negative, given that he or she uses marijuana. So let's do it. Let's start from A. Let's use uses marijuana. We're gonna use yes for that. Why? Yes, and then do not use marijuana. The subject do not use marijuana, right? We're gonna use no for that. That means N, which represent no. The next one is there for positive results. We use P for that. For negative results, negative, we use N for that. Negative results, we use N for that. Oh, okay. You know what? Let's use marijuana M. Yeah, let's use M for marijuana and then use M complement for the subject that doesn't use marijuana. Okay. Control. Okay. Then we have positive and negative. Now let's answer the first question. First question says, the subject tested positive, given that he or she actually uses marijuana. So we're looking for the probability of that he tested positive, given that he uses marijuana. Now, because I can't get the formula for this from here, we're going to use the workbook on the other side. Okay. So let me write this down on paper. P, given that he uses marijuana, will be let's go and write it for there. Okay, so I'm gonna take it to this place. We'll have say you know what? I'm still going there. We can just let me go back. Oh no, okay. Let me see the best way to do this. Yeah, we need to use this workbook to get it. The subject P uses marijuana tested positive. I'm gonna make this into be bigger. Make it 18, probably 18. Okay, positive results. Okay, given that he or she uses marijuana. Okay. Positive results. You know, he or she uses equals the probability of, I'm going to use numbers and number of points, and I put this positive and marijuana use divided by number of points And that the condition here is that they use marijuana. So you're gonna have M. Excuse me. They use marijuana. This will give us the answer we're looking for. See, positive and marijuana divided by marijuana use. So let's go and get positive and marijuana use. You can see from here that on the table, tested positive is right here. And yes, they use marijuana. So you can see this presents positive and yes. Yes, they use marijuana and this positive. See, you can see that intersection of yes, they use marijuana and positive result, 119. So you got 119. Okay. 119. Now, the number of points that they use, that's n number of points in uses marijuana. You can get that as well from here on the table. Okay. Have it here. Yes, they use marijuana and the total is 122. Yes, so yeah, gonna put 122 there. 122. 122. And that gives us equals 119 divided by 122. So 119 divided by 122. 0.975. 0.975. 0.975. But you can say that there is 97.5% chance that the subject tested positive, given that they uses marijuana. Okay. I have it right here. Okay. Positive, given that they use marijuana is number of points in M and P and M. You can see right here. Positive results. Yes, they use marijuana. You can see the intersection right here. 119, you can see right, 119. Divided by number of points in uses marijuana. Yes, they use marijuana. You can see right here. And total is 122. You put it there. When you divide, you get 0.975, which means there's 97.5% chance that the subject who uses marijuana will test positive. Okay, as B says, okay, the subject, the subject actually uses marijuana, given that he or she tested positive. Let me see if I can use writing to do this. So the subject uses marijuana, given that he or she tested positive. Okay, so let me see if I can write it with this draw. The subject P, okay, uses marijuana, which is M, given that they tested positive, equal, okay, equal, let me erase this to make it more clear. Okay, equal. So you're gonna have number of points, okay, and positive. Oh, actually, marijuana first. We have number of points in marijuana use. Okay, and positive results divided by number of points and this one, the top, well, make the top to look more legible. Yeah, number of point in marijuana use, and positive results divided by number of point in positive results, which will give us equals to, now marijuana use and positive results. You can see it from here. And see from here, marijuana use. We say this yes, they use marijuana and they tested positive. See, they said 119. So you're gonna find the same 119. So you're gonna be 119. Okay. Over number of points in positive, because this time the condition is positive. Okay. So you can see the condition right here, positive results. If you follow it to the left, it is 143. So you're gonna be 1, 4, and 3. And that will give us the answer right away. Okay. 119 divided by 143. In the calculator, you have 119 divided by 143. 0.832, rounded 0.832. Okay. 0.832. 0.832. Yeah. So that means 83.2% chance that it will be that the subject will be it will be uses marijuana will test positive. Okay. Now I try to write it down, but my writing is not that legible writing it, so I'm still learning how to do it to write it down. So let's go back to what we were doing before. He said last one says. He said, what is the probability that the subject tested negative, given that he or she uses marijuana? Okay. A tested negative, given that he or she uses marijuana. Okay. So in that case, we're looking for the probability that they tested negative, P negative, given that they uses marijuana. Okay. Like, I can't get this from here, and as you can see, my handwriting is not that legible. So I'm gonna do it on another workbook, so it will be more legible. So looking for negative, given that they use marijuana. So I'm gonna take you to that workbook. The subject tested negative, given that they use marijuana. So you can have the number of points in negative and marijuana use divided by the number of points in marijuana use. So I'm gonna erase this, the top one, so we can put the correct number there. Okay. Let me just look at the question again. The subject tested negative, given that she uses marijuana. Okay, good. We're on the right track. We're taking you to the other workbook. We have it here. I'm gonna put the numbers. I'm gonna clean this. So tested negative, that means negative and marijuana use, negative, and then number of points in marijuana use. So let's get it information from here on the table. This is negative result right here. This is, yes, they use marijuana. So negative and marijuana use, you can see that it is this one here. This one present negative test, but even though he or she uses the marijuana, he tested a negative result. So that's what this one is about. So we have 3 and divided by the probability of, let's do and put the 3 first. 3 over number of points in marijuana use. I say yes that he used marijuana is right here. It's 122. Okay. 122. Okay, I'm gonna be 0 point something. 3 divided by 122. We got 3 divided by 122. 0.025. 0.0025. Okay. I copy this and paste this right there. 0.025. Okay. That means there's 2.5% chance that a subject who uses marijuana tested negative. It might even be a false negative. Now, any question on this one? Any question?
No.
Okay, good. Now, I have shown you conditional probability. Now, let's look at another example in conditional probability. It's called the at least probability. Well, actually, conditional probability, not at least. It says 2 cards are selected in a sequence from a deck of 52 playing cards. Find the probability that the second card is a queen, given that the first card is a king. Assume that the king was not replaced. Say, assume that the king was not replaced. So, if you look at the cards, let me go and show you the cards again. Deck of cards. The deck of cards. Okay, we have a deck of cards right here. I can bring it down. Okay, so we're looking at it while we solve that. Okay. We have conditional. Okay, we want. We finish this right here. So see the deck. So you can see we have how many kings? 4 kings. 1, 2, 3, 4, 4 queens. 1, 2, 3, 4. Now it says here, 2 cards are selected from a deck of 52 cards. Find the probability that the second card is a queen, given that the first card is a queen, is a king. Assume that the king was not replaced. So when we made the select, we're looking for the probability that the first card is a queen. Sorry, that the second card is a queen, given that the first card is a king. Okay. Now, before you make the selection, there are 4 kings and 4 queens. So in the first one will be, it will be, but we're looking for the probability that the second card is a queen, given that the first card is a queen. Now, when we select this first card, there are 4 kings and 4 queens out of a total of 52 cards. Now, when you made the selection and then you got a king, but you didn't replace it, now you have 3 kings with a total of 51 cards before you made the selection for the queen. So the probability that we are going to be, there's still 4 queens, only king decrease, but the total of the card is now decreased. So the probability that the second card is a queen, will now be 4 out of 51 cards. Because now you didn't replace the king. And that will give us 4 by 51. 4 divided by 51. 0.078 rounded. 0.078. Answer. Right. Okay. So you have seen how we do conditional probability. I've shown you this. We'll come back to conditional probability again in a few minutes when we start doing Bayes' theorem. Now let's look at what we call at least probabilities. We call it at least one probabilities. In that case, so it's called at least one. So to solve this kind of probability, what we do, we use the complement rule. Okay. The probability of E equals to the 1 minus the probability of E complement. What this means is that when we're trying to find the probability of at least one, we get the probability of the opposite event and subtract the answer from 1 to get the probability of at least 1. Let's see how it works. Look at this example. It says a card is drawn, a game is played by drawing 4 cards from an ordinary deck and replacing each card after it is drawn. Find the probability of winning if at least 1 ace is drawn. So to win, you must have at least 1 ace. So that means if you don't get an ace, you lose. But you win if you have at least 1 ace. So that means we find the probability of the opposite event, which is no ace is drawn. And then we subtract our answer from 1 to get the probability of at least 1 ace. So let us use A to be at least 1 ace. The opposite event, which is the complement, A complement, is no ace is drawn. Now, if you look at the card, we have how many aces? You can see the aces here. 1, 2, 3, 4. Out of the 2 cards, there's 4 aces. Now, the rest are not aces. I mean, it's about 48 cards are not aces. And this game is played by drawing 4 cards. Drawing 4 cards from a deck. So let's find the no ace is drawn. So the A complement, the required probability of A complement, that means no ace is drawn, will be 48 cards are not aces out of 52 are not aces. 48 out of 52 are not aces. Okay. Now, because it's drawn 4 times, 4 cards, right? That means raised to the power of 4. Okay. Raised to the power of 4. I mean 48 over 52 times 48 over 52 times 48 over 52. So raised to the power of 4. Remember, not times, but to the power of 4. That will give you the probability that no ace is drawn. So 48 over 52, we got 48 over 52, okay, raised to the power of 4. 0.726 rounded, 0.726. 0.726. So that means this is the probability of the opposite event. That means no ace is drawn. But we are looking for the probability that at least 1 ace, is drawn. That means we're gonna use probability of at least 1 ace. Okay. P of at least 1 ace, that means A will be equal to the 1 minus P of A complement. Okay. That means that will give us at least 1. Okay, that will give us 1 minus 0.726. Yeah. I'm gonna write this down so we can subtract it. 1 minus 0.726. Okay. I'll go and get it. 1 minus 0.726. 0.274. 0.274. Okay. 0.274. Okay, or there is 27.4% chance of winning the game. Okay. So that's how we do this at least probability. You can try some examples I have here for you. Let's go to the final, which is Bayes' theorem. Bayes' theorem. Now, the Bayes' theorem basically is a type of conditional probability. Okay. Now, it is used to calculate the probability of event A given B from the information about event B given A. So this is how the formula looks like. It said the probability that event A1 will occur, given that event B will occur, means the probability of B given A1 times probability of A1 all over P of B given A1 times probability of A1 plus P of B given A2 times P of A2. And if there are 3 events, we use this formula right here. Simple, just extend it. If there are more than 3, you can just keep going. So remember that the denominator is we have all the events that are given to you, all the conditional, that some of them are involve conditional probability. Excuse me, like here, you have probability of AI given B equals probability of B given AI times P of AI over, you repeat the same thing right here, then plus from other events that are given to you that were called a priori events. Look at it, says, according to this Bayes' theorem, suppose 2 events have prior probabilities, PA1 and PA2. Then A1 and A2 are called prior probabilities because they are determined without any other information. So that our goal here is to find the posterior probabilities, PAI given BI. So well, we call them prior and the posterior. It just means the probabilities before and after observing the event PI. That's what it means. Anyway, the formula might look like a monster here, but as we use it in 2 examples, it will be clear. Okay, let's try this example here first of all. It says here, let me make it a little bit bigger. Probably 16 will be good enough. Okay. So 2 events. 2 events A and B. Sorry, my mistake. Let me make sure you see this. So a book club classify members as heavy, medium, light purchasers. I think water. So a book club classify members as heavy, medium, or light purchasers, and separate mailings are prepared for each of these groups. Overall, 20% of the members are heavy purchasers, 30% medium, and 50% light. A member is not classified into the group until 18 months after joining the club, but a test is made for the feasibility of using the first 3 months' purchases to classify members. The following percentages were obtained from existing records of individuals classified as heavy, medium, and light purchases. You can see this here, heavy, medium, and light for the first 3 months. This one means first 3 months purchase. This remains no purchase. 1 purchase, 2 books bought, 3 books bought, And these are the probabilities for the medium, light, and heavy. So if a member is choosing, if a member purchases no book in the first 3 months, what is the probability that that member is a light purchaser? So let us use, let me see, solution, okay? Let us use L for light purchaser. Then H for heavy purchaser. Oh, excuse me. Heavy purchaser. Okay, and then can use M for medium purchaser. Purchaser. Okay, as well, I've identified them. Now we're looking for the probability that it says if a member, make sure I'm saying this. So if a member purchases notebook in the first 3 months, what is the probability that the member is a light purchaser? So we are looking for the probability that the member is a light purchaser, given that he bought notebook. See, that's what we're looking for. That he bought notebook. That we're looking for the probability that is a light purchaser. So I'm going to write the formula for this. This space will not allow me to write it. But before I do that, I want to identify what they say on the paper question. The first one, we have identified what a light purchaser is, right? See, overall, 20% of them are heavy purchasers. So we have that heavy purchasers, heavy are equals 20% of them. I mean, 20%, which is 0.20. It also says that 30% of them are medium purchasers. So you have medium purchasers equals 30%, which is 0.20. Then light purchasers are 50%. Okay. Lights are 50%, which when you change it to decimal is 0.50. Now, with this and with that, we are also giving other information from the table for those that heavy purchasers who did not buy any book in the first 3 months is 5%. Medium purchasers who did not buy any book in the first 3 months is 15% of them, and light purchasers who did not buy any book in the first 3 months are 60%. I mean, there are 50% chance they don't buy any book, that kind of thing. So that's what. Now, with having this information, now we are ready to calculate the probability that the member is a light purchaser, given that he didn't buy any book. So we can now write the formula. I can put the formula on the next the other slides where it will allow us. We are looking for the probability of is a light purchaser, given that he bought or he or she bought no book the first 3 months. So it's gonna be probability of, okay, you have 0 book given a light purchaser, okay, times the probability of light purchaser. Oh, excuse me, sorry. Times P of light purchaser. Okay? Then repeat it under and put the other the probabilities. Probability of that the person is 0, given that it's a light purchaser, times the probability that it's a light purchaser. Okay. Then I'm gonna then plus this kind of, but remember we're using the bias. This is that question is a good candidate for bias formula because they give us the prior probabilities, which is 20%, 30%, and 50%. And then they give us the other probabilities. So this is a good candidate. And the formula we're using is this one here. So we use a L to represent A, live purchase, and then B to represent the zero purchase. Okay. So that's what I'm doing actually. So we have this for now, plus the probability of, okay, zero purchase, given that the person is medium purchaser, times the probability of medium purchase. Okay. Then plus, I'm going to remove some of these things here because they are blocking. Plus, the last one will be for heavy purchasers. Probability of that he bought no book, given that is a heavy purchaser, okay, times the probability of heavy purchaser. Heavy purchaser. That's what we're gonna use here. Oh, excuse me. Let's see. And then we have this. Okay. I'm gonna remove this. That's the formula we're using. So you have zero book was bought. That's the heavy purchase. Okay. Times the probability of heavy purchaser. That's what we're going to be using. So I'm going to copy this formula and paste it in a main workbook. And we can now come and replace them with numbers. Okay. Right here. Okay. So that's the formula. Now we can now replace all this with numbers. For example, P that the person is 0, bought no book, given that it's I should put not L, I should put L here, not P. Let me go and correct it. As live purchaser. Live purchaser, okay. Okay, let me say copy it. And I can show you the individual probability so you can see what you're about to put there. Cool. So the probability of 0 that the member bought no book, given that it's a live purchaser. Say, look, bought no book, given that it's light, which is 60%. Okay. Times the probability of live purchaser. We have it here. Is at 0.5. See? So we're gonna go and put it right there. So this part, bought no book, given that it's a live purchaser, is right here. 0 book, given live purchaser, which is 60%. Then times the P of live purchaser, that means times L, which is 0.5. So let me write it here. Now we have 0.60 times 0.50. Let's go and put it right there. So you have 0.60 for this one. 0.60 times 0.50. Then repeat the process here. Okay. 0.60 times 0.50. Oh, excuse me. This here. Now, plus, now let's get this part, this one. I'm going to show you on the other workbook. We got here. Bought no book, given that it's a medium purchaser. See? No book was bought, given that it's a medium purchaser. That means 0.15. 0.15. Okay. Times probability of medium purchaser, which is 0.20. So let's go and put it there. Okay. We have so we're gonna have here for this one, we're gonna have 0.15 times 0.20. We close the parenthesis. Okay. Plus. Now let's look at this part here. This is this one. I'm gonna show you on the other side. The probably that they bought no book, given that is a heavy purchaser. Bought no book for heavy. I mean 5%, 0.05 times say times the probability of heavy purchaser, which is right here. Heavy purchaser, this is the probability. They have 0.20, 0.20. Okay. So have as a matter of fact, medium purchaser was 0.30. I wrote 0.20 here by mistake. 30. So you gotta be 0.30 on that side. But for heavy is 0.20. Okay, 0.30 right here. Heavy 0.30. So we have 0.5, 0.05, 0.05, okay, times 0.20. And that will give us the answer we are looking for. So we have all this. Okay, let's go and put this in the calculator. And we'll get our answer right away. I wrote it on paper, so it's easy for us to put it in the calculator. Okay. Now clear this. We have yep, 2.60 times 0.50. Okay. Divided by 0.60 times 2.50. Okay. Then plus 0.15 times 0.30. Okay, plus 2.05 times 2.20. 0.845. 2.845. 0.845. So I'm gonna make it probably 16, font size 16, and then copy this and paste it right here. I'll give an answer. See? So that the probability that I'll put that this way. The probability that, remember, who purchases notebook? Let me write it down here. Let me write this interpretation. So that the required probability that the member who purchases notebooks in the first 3 months. Okay. Who purchases notebook in the first 3 months is a live purchaser. Purchaser is 0.845 or 84.5%. Yeah. This is Bayes' theorem. This is exactly the Bayes theorem. This is the type I'm gonna give you. So this type I'm gonna give you as a classwork. Any question before we round up? Any
No.
question? Okay, good. So the homework that is due this week, I'm gonna extend this to next week since we haven't finished yet. We still need to do the counting rules. And this one, counting rules. So we'll start that next week. So I'm gonna extend the due date of this homework that is due this week. I'm gonna extend the due date to next week. Then I'm gonna put the classwork for you. For your classwork, the one I did say to calculate the probability that the member who purchases notebook in the first 3 months is a light purchaser. Then this one I'm gonna say is a heavy purchaser. Let me make it heavy purchaser. Okay, there's the same question, but different heavy purchaser. So let me copy this and put it on the classwork so that it will be available for you. So this time is a heavy purchaser we are looking for now. Yeah, I'm gonna put it right there for you. Take you to the classroom. Okay, see, that's a classroom right here. Okay, I'm gonna share it with you. So I'm gonna change this classwork with this Bayes theorem. I'm gonna change this to this one. Remember to show your work. Don't forget. Put this right there for you. It's a light purchase. It's a heavy purchaser. I did light purchaser. So you do heavy purchaser. Okay. So that's what you're gonna do. Make that is due tonight, but tomorrow, tomorrow. So save and publish. So you have it now, the classwork. Now, the homework that is due today, this week, is probability. So I'm gonna extend it to next week. So we can finish, we have more time, and then we can finish the whole topic. Let me extend it. Okay. I'm gonna move this up. Okay, this is the homework. What is it? Yeah, it was. Oh, actually, it was due in October for you guys. So it's due in October. Let me see. See, homework 5, probably this is 10, October 6. So I want to make it due on October 6 as a matter of fact. We should be, yeah. But I did it already. So it's due next week, not this week. So I think you're good. You're good to go. So having said that, I'll come back to this place. Okay. Change this to light here. It was light before. All right. Let me look at my attendance and then you can leave. If you don't have any question, you can leave. Is Boston Cedric here? Not here. If I don't call your name, that means I have it here with me. Yes. Is Marcus Graham here? Is he here?
Yes, I'm here.
Okay, let me put here. Let's check it again. Derek Maison, is he here? If I don't call your name, know that he's not. I have it. So he's not here. Machuku is not here. Alyssa Parker is not here. Rachel Parrish. Peacock, are you here? Peacock? Morgan Peacock, you here? Okay. Kennedy Reagan's not here. Simon Douglas, not here.
You said Eric?
Huh?
Eric?
Eric, I have your name here.
Okay, great.
Talking about Reagan's Kennedy. I don't have it here. Douglas Simmons, you here? That's more this name. Green Epiphany Green. here. Have most of them here. Yeah. Daily Kimura. Have it here. Graham, still Graham now. Okay. Now, McCoy, you see here?
Here, I'm here.
Okay, good. Peacock. Yeah.
Did you say Chantal Brooks yet? Or no?
Yeah, if I don't, yeah, I didn't call you because I have yours here already.
Okay, thank you.
Yeah, you're welcome. I'm calling those that I don't have their names here. Okay. Else. Gross. Harris. I have Harris. Okay. I mean, March. All right, guys. I'll see you guys next week then. Enjoy your weekend.